Sazzala Reddy, welcome to the vBrownBag Build Day with Datrium.
Thanks, Alistair. I'm happy to be here.
And Sazzala, the particular reason we wanted to capture you was that you were very much the architect of this data protection, VM protection that we did, and we set up some policies to protect some VMs, but I wanted to go through with you what the architecture was, the thinking and the philosophy around how that was set up, and particularly look a little under the covers.
Yeah, great. So previous to being a Datrium co-founder, I was the CTO of a company called Datrium.
I think we know of that
Right.
organization as well.
Yep. So so I had a privilege and being lucky to meet a lot of customers in that while I was there. And what I found was that the backup and data protection seems to be a pain everybody faces.
I think everybody has a favorite backup product, and it's the one that they're about to deploy.
Yeah, that's right. I think before Data Domain, there was tape. It was even worse than that. So Data Domain made the pain easy from that angle, but still backup remains a big pain. And having studied that for a long time, so we had some interesting ideas, and having personally experienced and people's pain. And if you ever met any backup administrators, they'll tell you how
they have less here than I
have. Yeah, they feel the pain every day. So we're like, okay, how do we kind of make this change? And also, there is a transition to cloud. There is a transition to having less budgets, and mostly the roles are converging, and there's no longer this multiple people doing multiple things. There's one person generally trying to do everything.
But
right?
at the same time, as you're getting less people, you're getting much more aggressive recovery time and recovery. Data loss windows are being squeezed and squeezed.
That's right. And if you have like a 1 petabyte of data, it's no longer that easy to move the data and back up somewhere else.
Bulk copies become
it's just hard. And then if you really have a disaster and you're trying to recover all that stuff, it just becomes unmanageably hard to do all this. So we thought, let's just do it differently. And given the background we have, and I think we kind of understand the pain, and we have felt the pain from previous experience. We said, okay, let's just do something different and better for the customers.
Let's continue to build on what we've already developed and build something better. Right.
And then the other thing to notice is that you must think of, in a storage industry is like, if you look at the architectures, if you don't build something from the beginning, if you have not thought about it, it's very hard to retrofit. So that's why I think from the beginning, we had the goal to tackle data protection early on. So we have built foundationally from day one, how are we going to do this? So it's not a new thing we suddenly started, but it's built into the system from day one.
And the same as the data efficiency features of dedupe and compression. Bolting those on afterwards is a nightmare. But
that's right, exactly.
Building them in and having them as almost an immutable part, you can't turn them off.
You can't turn them off. So exactly. So if
you can leverage them.
That's right. So if you see any vendor having a knob to turn off something, it means it doesn't work very well. Like Data Domain had dedupe on. There's no turning off. Pure, for example, has no knobs to turn off dedupe. So if anybody has a knob, my experience has been that marketing wanted that knob, and that's for a checkbox, and they added that later on, and it basically is off by default because it doesn't work well. So to avoid all those problems, we thought really deeply about it. We invested a lot of our effort. We have a good team to go and build the foundation of data efficiency, because there's a foundation, and then layer things on top of it.
Yeah, great. So let's have a look at.
You got
some slides to show us.
Yeah, I got a couple of slides. This is the picture which probably you've seen before. Most companies.
The sea of complexity.
Yeah, right. And this is surprisingly how a lot of people do have the setup. Like they have the VM servers, they have the SAN for storage, primary copy, and they have a SAN switch to manage, and then there is the backup software to manage, and then there is the proxy servers, and then there is the backup boxes. Another bunch of disks to manage.
The secondary copies.
And then you have to have WAN replication because you want to do DRs protection somewhere, and you replicate the whole thing on the other side. Ultimately, if you look at the number of boxes, number of people you need to manage, it's like there are 3 people to manage all this stuff, and there's multiple UIs to manage, multiple things to learn from you. And ultimately, what we found is that Dell did a study on this and said about a big chunk of this much of complexity makes recovery actually harder. You actually lose because you can't know what you did, what you didn't do, and then it becomes really hard to do this. So the question we had was, if you look at the slide, what if you remove all this? What if you remove all of these pieces and made it quite simple? What's stopping us from doing this, right? What's stopping us from doing the unified way of managing this?
Build it into the core product rather than a series of bolt-ons.
Yeah, there's a bolt-ons, right? So why not just do this? Because it is a hard project, but if you spend the time on it, if you think of the customer's perspective, then you can do this. It's possible, and we have demonstrated we can do this. So the question, is that why should we do this, right? I mean, I just explained the complexity, but there's some other truths about it. Like, it's not just backup, it's the long-term archiving. There is now the cloud backup, and there's encryption. There's other policies, there's DR. I mean, it's not just backup, it's the other data management. It all falls under the data management. It's a wider picture, right?
Yeah, the use of copies of primary data for test and dev and user acceptance and e-discovery and all of those
all of that
pieces.
stuff. Like, how do we make it really good and really easy to use? And if there's only one administrator or one type of administrator, can they all use it without having to learn complex stuff? How do you make it all, and how do you also present this as a usable, simple interface, right? So that's the thing to think about. And so what are the driving forces for unification? I'm calling it unification or convergence. You can call it both. It's economics, number one. It's the cost and the ease of management, and basically the less maintenance. You don't have to maintain, upgrade all of these systems.
Separately,
like, I mean, you have to kind of...
But with interdependencies between which ones you can upgrade when, and
exactly.
you get into the dependency hell.
And one of them doesn't work with the other one, they have to call up support and okay, this doesn't work, okay, they have to triage it. But if you had like a unification, there's convenience in that, right? Ultimately, there's a cost and the maintenance hassle, and then there's convenience. Like, how convenient is it for me as an administrator that I can do my other job, which is to manage the apps, manage the business. I don't want to manage hardware anymore. I want to manage the business. So it's a convenience, pure one interface, easy to use. It just simplifies everybody's life. Today we are in the world of consumer UI. I mean, like, why are we still stuck in the past, right?
Why is this harder than my iPad?
Right. Yeah, exactly. Right. So, and then the other question is, okay, we have made the case for why we should unify. The question is, why now? Why wasn't it happen before? Like, why is it that we can take this challenge now? So the important thing to notice is that VMware changed everything. To be so honest, on virtualization, but VMware is a big proponent. See, before VMware, there were all these esoteric, hardware, like AS400, IBM mainframe, and you had all these other things, and Solaris something. So you needed a heterogeneous way of being backup, and there was no easy way to do this. I mean, the incumbents had a strong strength in that because they knew all this hardware topologies and
that have agents for each of the various operating systems.
So it's very hard, right? It's very hard to enter that market and do all this stuff because you no longer. I mean, it's very hard. It's a very hard science,
and it's all fragmented.
It's all fragmented. So, but with VMware, what has changed is if you just back up, if you understand what VMs are, and if you can just back up VMs, you've done 80% of the job, right? There are some things
we're not replacing the application level backups, as Devin and I discussed earlier, but the fundamentals
are there.
The whole VM back.
It's an easier bar to get to, and with VMware and virtualization being here, it becomes much easier job to do that. That's why there are a lot of new entrants in the market, like Veeam, for example. By the way, Veeam has just crossed revenue of Commvaults. It says something.
So they exceeded Commvault. They've been in the market for, what, 30 odd years?
Yeah, exactly.
Wow.
So maybe not 30, maybe 20 plus. And Veeam is a new entrant, only does VMs.
Only does virtualization backup.
And they have taken over Commvault. I mean, Commvault is legacy. I mean, yes, it is true. Some people have AS400, IBM, whatever.
For those
people, sounds great. But Veeam has, I mean, I'm telling you that the virtualization has made all of this easier. So once you understand what a VM is, then the next thing is that you can build primary storage specifically just for VM awareness, right? So that's the new entrance you see, like hyper-converged people and like us. We understand what VMs are fully. And then once you know how to do what VMs are, you can do primary storage with VMs, provide higher level conceptual simplicity. And the next thing you can do, if you can do that well, is like us, build in backup. Because then you know what VMs are and you can do primary storage because the VMs live on you, then you can just make backup just much easier. So the question then is, okay, we made the next case for why now. What does it take to do primary plus backup? Like what do you need to do? First thing you need to do is understand VMs as first class objects. You need to know what the VMs are. You need to provide VM-based policies to have a protection policies. And you need to make it easy. You need to build some of the backup features other backup vendors have. There's a reason they have those features, like single file recovery, like object level recovery, those kind of things you need to build. And ultimately, you need the easy button. It's got to be easy. If it's more complicated.
Yeah, that's the easy button, simplifying everything, making it, removing all of the complex interdependencies is the big trend in the last 2 years.
Yes, exactly. So, I mean, you set up policies and you forget about it, right? That's what you want to do. Just forget about it and then just move on. So the question is then, why can't SANs do this? Like, why can't like regular Nimble or Pure, why can't they do this too? I mean, they have snapshots. Why can't they do this? It's very hard for them because they don't know what a VM is. They only know LUNs. who wants to back up LUNs? I mean, it's not, doesn't apply, it doesn't map to your business.
Yeah, the granularity of policy needs to align back to the business requirements
exactly.
for the workload.
Right. So, and LUNs don't map to the business requirement. They're an artifact of some old 30-year-old.
You can make them.
You can make them,
but that's another thing that you have to manage, is that mapping of this collection of VMs have to live on this LUN because this LUN has this replication schedule and this backup. Yes.
Actually, I don't even think you can map that easily. I think you can try to, but I think most people
I've seen the spreadsheets. You can do it, but you don't want to.
Yeah, exactly. So that's going to becomes a harder thing to do. And also then let's say they figure out some way to do this. Then you need the next layer of efficiency. You need global dedupe. You need to use hard drives. If you do all flash, you cannot still not cost competitive to do backup. I mean, there is these issues, right?
Harder to, yes.
And not everybody has global dedupe in their architecture. And more importantly, what I found is that these are all technical reasons. These are all but more importantly, it's a mental problem. Is that you need to have empathy for the end user. Like you need to think about the backup admin problem. So a lot of people, I mean, I'm not saying negative about them. It's just that have you been there before? Have you understood the problems the IT administrators have? Like they're solving one part of the puzzle, like storing primary storage. But have they understood the whole data management aspects of it? It comes from experience and just having some empathy for the end users. If you go to the data center, don't just talk to the primary storage guy and talk to the other people in the team, and you'll need it. You know that there is a pain everybody has. So it comes from that basically fundamentally. Technology anybody can build. It's did you understand the problem that facing in the entire data center, right? So what did we do to solve this? Like, what did we do? So we have unified it. We make a very simple system, very easy to use. It's converging compute. Compute also is another thing. Hyperconverge, right? Why is it successful? Because they're making it easy. They're converging a few things. We took the next step of converging even backup. So compute, primary storage, backup, and disaster recovery, and backup to the cloud. And all of these things with us, you can call one phone call, you can solve all of it, and it seamlessly works with all of these pieces. It's well integrated, well tested, and you have a single interface, very easy to use. We've really worked hard on making the interface easy to use. And we have a small footprint. You don't have to manage lots of stuff.
Lots of different devices.
Right, and we're very efficient. Cost efficiency is very, very good with us. And that makes it actually legit. Like it makes it actually possible, cost effective to do all this stuff. And so again, going back to the legacy, there are so many pieces involved. There's CPU cost everywhere. You have to have the backup proxies and all those things. And then you need multiple drives and catalog. So we took all of that and said, okay, how do we converge all of that into our system? And if you want to do a good job of trying to say that you need to, sorry, this slide. I have a few slides. HCI is the same thing. Yes, they've solved some problems, but still the backup remains to be a challenge for them too. I think HCI, one issue is that it's built with 3 copies because each node is kind of separate. And if a node goes down, you need another copy. So then they do, erasure coding is hard unless you build from beginning. Again, it's one more thing. Erasure coding, you must build from scratch, from beginning. Otherwise, it's really hard to bolt on. So if you have 3 copies of data and dedupe doesn't really work well, then how do you have like lots of copies of backups?
Lots of backups.
Yeah, then it kind of becomes expensive then you have to buy another backup system because you have to. There's no choice.
Or you're just buying more capacity.
You're just buying more capacity, right? I mean, and that becomes a challenge then. Sorry, I have a few. Okay, so back to this one. Oh. All right. So the secret sauce, what is our secret sauce in doing all this stuff? So we have a scale-out software controller, which is kind of does it all. So it does inline erasure coding, inline dedupe and compression, all those things with the encryption on. So we made it really work well with a really high performance. So that's number one goal. Number one goal is that if our primary storage doesn't work well, what have we done, right?
Yep.
Then we're just a backup vendor.
Second goal. First goal is always return the data that was stored.
Oh yeah, sure. I think that's a given. So we have really worked hard on making sure that we have all the checksums, end-to-end checksums. We scrub the data all the time.
But performance and that distributed controller through all of the compute nodes.
Right. So we recently published an industry benchmark from IOMark because we wanted an industry validation, not some homegrown, some FIO thing. We have those too, but we wanted industry validation. So we have beat other benchmarks by 10x. So And to just prove that it is actually works the way we said it works,
Yes.
and with no knobs,
Nothing to tune.
nothing to tune, it just works. And so very high performance, very high ingest rates. And the next thing is we have all the data reduction, which really helps with the doing the backup kind of features. And we have encryption, as you know, already talked about it. So then how did we do data? How did we do data management? How do we do data management in our system? So we know what VMs are. So, but the problem with LUNs was that you don't know what they map to, what's inside of it. But the good news about LUNs was that there are a couple of good points, though. I mean, it's hard to say what good points are, but I have come up with 2 good points to say about them. One is that there are less of them.
Yes.
Like there are less of them.
You can a container for multiple VMs.
Right. You can click on a few of them and set policies. It's possible. The other good thing about them is that when you take a snapshot of a LUN, all the VMs in there get snapshot together. So if you want consistency, right? So if you have a multiple VMs, sometimes you have multiple VMs. You have a database 1, you have a web server, all that stuff. If you do backups, like one by one, they come with different points in time. So when you try to recover, what did you get? You got all these different things.
Which point in time did you recover to?
Yeah, exactly. And you got different things at different times, and how do you put it together? So I never understood that. But LUNs, the good news about them is that if you put all the VMs in the same LUN, if you manage to, then you can snapshot that LUN and you end up at the point in time. That's the good news about them. But if you go back to the VMs again, like the problem with VMs is that if you have lots of VMs, hundreds and thousands of VMs, right, these days, you can't click on every VM to set policies.
It's not a human scale.
It's not a human scale, and then you're like, and then you hate your life. You're like, you're back to the problem. Okay, I'm managing too many things. Like, so we've done some innovation on that. Like, how do we scale? How do we manage set policies at scale? And how do you do consistent snapshots, right? And then once you have done that at scale, then you also want to drill down. Like, how do I, once I've taken all this high-level view, when recovering, I want fine-grained recovery.
Very detailed.
You want very detailed recovery, and you want to be able to find those things. And once you have a million objects of snapshots, how do you find these things? Like, I have thousands of VMs. I took millions of snapshots. How do I find my objects, and how do I operate on them? That becomes the next problem. And then, so what we decided was, okay, so in generally VMware, there's the live data store, right? There is the VM store or live data store, which is where the VMware wants to project. You want to see all the VMs. But we built another a database called Snapstore, appropriately named
for holding snapshots.
We built a separate database. It's really fast. It's a kind of in-memory database, but of course it's on disk too. But it's an in-memory database where the queries are really fast. Like they're like nanosecond, millisecond kind of latencies. So all the policies are held there. All the global policies you set, and also all the snapshot metadata is held there. The underlying data architecture is all shared data, yes, but the database
there's one dedupe store underneath and two ways of accessing it.
Right, 2 views, like you mentioned before. There's 2 views to view it. Each one has its own way of looking at the live has its own way of looking at it, and then the Snapstore has its own way of looking at the data, and then it has a little bit more database properties to like query things and fast accesses. But you also made sure that we kind of spent time on making sure that, if your live VMs are down, it's a P0 escalation. If your backups are down, it's a P2 escalation kind of thing. So we tried to make sure that that there is no interference between the live and the backup. So that also, one must think about it, like, from a customer end customer point of view. Just because you did snapshots now, is it affecting my primary storage? So we tried really hard not to have that. We kind of separated them out so that there's no interference between those two views. Then from a policy perspective, what we have done is that we have something called protection groups. It's not a new name; it's a common name. We didn't come up with a better name than this. So what you can do is that you can make a few policies. You can say gold, and you can say gold. I want the policy to include all my SQL servers and my web servers. So there could be many. So most people have naming conventions. So it's very easy to set up, okay, SQL star. It means it'll pick up any VM with that SQL as a naming convention, or your web server star, and then it'll pick up all those names. You can also pick individual ones if you care to, but you can just set up these policies, and automatically, dynamically, we will figure out on the fly the change of these.
If a new VM is created that matches the pattern.
Right, exactly. Or the VM is deleted, it'll just delete it. It'll remove it from the list. And then, so when we snapshot them, for example, you can say star. Star means everything. you can have 6,000 VMs. We will snap them all together at one shot with no performance impact to anything. You'll see it's a glitchless snapshot.
Because it's the underlying
deduplicated
storage system, and it's just a metadata.
It's metadata
Pointer that's being
metadata
duplicated.
point in time. Yeah. So the advantage is that you don't have to worry about is it going to impact my is it going to stun my VMs or is it a performance impact?
And that allows you to do continuous backup through the workday through production, which of course now is 24/7 anyway.
Exactly. In fact, our QA, because we have millions of snapshots, it takes a long time to test. Like, and if you really think about it, if I set a policy for a daily and then have a million, it'll take a million days. So how do you make this faster? How do you test this? Right, have a QA. So what we have is internally we have 1 minute snapshots. You can't take 1 minute snapshots. The UI exposes 5 minute snapshots or 10 minute snapshots at the minimum, but you can go down below that and then say 1 minute snapshots. So our QA folks they have 6,000 VMs. They set 1 minute snapshot policies because it's faster to test.
Yes.
Like the policies faster. Not always, but sometimes they do this because it's convenient.
But that'd be around 1,500 snaps a day per VM to get to your million snaps.
That's right. So I mean, you gotta expedite this, right? So that's kind of what we have done is that you can take snaps as many as you want. There's a limit, a million, because we had to put a limit because for testing. Otherwise, you say infinite. I don't know what that means. How do you test this, right? So we decided to keep a number. I think a million is pretty good so far. So that's kind of what we try to do is make it easy and make it effortless and not think about it. There's no stun times. There's no need to worry about any of this
impact to operation.
And because of the architecture we have, the dedupe and the data nodes, it's very cost efficient. You can just scale. You have more snapshots. You want to keep more backups. We have customers now who want to keep 4-year backups. They want to keep 4-year archives. Okay, go for it. Because they want to keep daily snapshots.
That's all of their long retentions.
That's right. And you can have hundreds of VMs, thousands of VMs. It doesn't matter. You don't have to think about I have to click only 200 VMs in my policies now. Just star. You can do whatever.
And those policies are both local snaps, but also replication to a remote DVX
exactly. So when you set up these policies, you can also say, you know what, every hour you take a snap, but every other hour you replicate to the other side too, and you can have different retention on the other side. And because we have global dedupe end to end, what I found is that not many people have global dedupe end to end. So it's interesting. So the reason it's advantageous is because if you have multiple VMs, sometimes you have the same data. A lot of times
you often have the same operating system,
right? Exactly.
Same patches.
That's right. So no matter how it ended up there, you can have multiple sites replicating to the main central hub. No matter how the data has come, right? You end up negotiating with the other side, saying, "Do you have this?" And yes, I have. Most probably they have it, and then you don't have to send all this data.
So if I've got lots of branch offices, they've likely got the same databases being sent down, and so we're only going to have to send back to. Actually, they probably came from HQ, so we don't even need to send a copy back.
That's right. We also done other interesting things like some of our workflow things, like you can click on a VM and say send this one time to another place, like just replicate it. Because I'm trying to if you have a remote data center, remote office, and then you want to just seed it. You can just send this one-time thing.
Send a snapshot, and then later I'm going to migrate the live VM, and there'll be far less data to move at that point.
Right, that's right.
Nice.
And the other thing is that it's not just VMs in your business applications. Sometimes it's also the ISOs and OVAs. So we also have that policies, and in a policy you can not only just pick VMs, you can also pick other objects in your system. Because what about those? Who backs them up, right? And you did all this. Sometimes you have a golden image. Where did it come from?
It's funny you mention that, because that was a policy that I set up. Devin and I set up a lead level protection for my environment, which is the lowest common denominator, and it included ISOs and floppy images, but I missed OVA files.
Right.
Yeah, but that's all backed up infrequently in my environment, just as a lowest level catch-all.
Right. Actually, by the way, you can set up a policy to replicate them every minute, but then if nothing changed, it will send nothing. Right.
And it affects my budget of a million snaps. So,
sure. That's probably fair. And then for replication, so we have topologies. It scales quite well because we've done the replication a little differently because we have host-based architecture. We use the power of the servers. Each one has a little bit. But then together,
this comes back to we have a storage controller in every one of our ESX servers, and it's the storage controller that does the replication, not the disk shelf.
Not the disk shelf, exactly. And it's coming from local flash generally. All those replications. Of
course, because it's a read access that comes out of the flash.
It's very fast. If you really have a local LAN, it's super fast. If you have a WAN, we have some settings. You can throttle the settings, and you can say, okay, I replicate only this bit. And we have a good system of alerting you, like if something is falling behind, we'll tell you what's happening, and those are the kind of things we have done.
We're not making our policy compliance, because that's the other thing is policy-based management means you don't have to look at the logs of the successes. You only have to be alerted for the failure to comply with policy.
Exactly. Like if you said replicate every 1 hour, but then it's falling behind because of the wire. I mean, the network is too slow, whatever, or too much change rate. Because you want to know, because you have to tell your other application people, your database.
It's a business risk.
Business risk that it's not happening. Then either you need to change the pipes to be faster, or you need to do something to make it. So we kind of make sure that we don't tell you success, we don't tell you like failure, so that you kind of not alerted too often. Who wants to get our emails every day, like, so.
I'd like one a day telling me everything is good and I can go back home at 9:30 in the morning because all my job's already done, because I'm only a backup administrator.
I've asked the question to customers and they said, I don't want to know anything. I just want to know if something has gone wrong. So, so the next thing we have right now is that sometimes some people don't have a second data center, because the CIO said, I don't want to pay for a second data center. It's only for DR, but all these expenses, I'm buying all this legacy architecture, like, primary storage and backup servers, everything again in the data center. Or to put people to manage it.
And we only turn it on once a year when we do a DR test.
Exactly. So we are like, why do this? And also, I met another customer recently who said they have DR offsite replication to Houston and Florida. Both of them got wiped out. He's like, I need to do something about this. So we are now offering a cloud backup offering. So basically, think of what is our product just offered there. It's seamless. It's managed service. Like, you don't have to do anything other than your credit card. You need a credit card to charge, of course. It's not free.
Because you're going to need some storage somewhere.
Yeah, that's right. So when you set it up, it's like when you set up a replication to another system, it's the same. It's that easy. You set up the same way policies to replicate to our cloud backup offering. It's a managed service. It means that we will take care of managing it. Like if it goes down, we'll bring it up, we'll upgrade it, so that you don't have to worry about managing it. So basically, it removes it's like a SaaS application. It removes your burden on you to do all this stuff. All you need to do is just set it up, and then all you need to do is decide that you want this, and it just works for you. And because, as you know, public cloud is not cheap, so global dedupe is important.
It is. Right?
You can't just send fools once in a while anymore.
It's you're paying for capacity every month. Capacity,
yes, exactly.
And transfers out.
Transfers out. And so the typical way backup software do this is they do fulls once in a while, and they do incrementals, right? So the problem with fulls once in a while, incrementals first, let's say weekly fulls, right? That all is ending up there and is eating up all the space over there. If you have tape, maybe it's okay, but for tape, there's no choice. There's no choice.
No cloud tape service.
There is no choice like that, right? So you need to do this in the cloud. So without global dedupe, with basically multiple VMs getting there, you don't get the savings. If you do fulls and incrementals, then every once in a while fulls, you don't get the savings. So you need to figure out how this is going to work. So what we have done is that we have end-to-end global dedupe, the same way it works. We have incrementals only forever. And the other thing is that once you have something there, you want to search for things. So we have a global search. You can, on your on-prem box, you have something. You can search through here locally. You can also search globally and say, okay.
So you have the full catalog of the replicated data on your local.
We query. No, it's not like that a little bit, but we kind of query. We kind of capture some information and so it's easy to query.
Right.
The queries are fast.
And I was just thinking, it's not even an incremental forever. It's a unique data incremental forever.
That's right. It's unique incremental data forever. That's right. But when I say incremental forever, what I mean is that
we don't do a periodic full.
Right. And let's say. And then there actually is quite interesting use cases for global dedupe. Like, people say it's technology, but no, actually there's some use cases. For example, if you are starting off with having 100 terabytes of data in your local on-prem, to start the seeding, if you want to seed that data, it takes forever. Like, it took forever. So we'll at some point offer a service where you can just, Amazon has a snowball service, you can just package it up. So if you package it up and send it there and you just dump it into the cloud offering, it doesn't matter how it's dumped there. Next time, then you start seeding, it'll detect everything's already there, and then don't have to send all this data over again. So there's some other advantage of global dedupe. And the other, not talked about much advantage of global dedupe is because the way we do it is content addressable system. Like, how did you know that what you sent actually ended up there? Like blockchain. Yes. So we have kind of like blockchain in the sense that we can determine that what we believe we got and we got.
But you can do a reverse validation. The data stored matches the address that it should be stored at.
That's right. So we check data at least once or twice a day to make sure that everything is consistent. And I believe, and also when replicating some other place, before saying we did it, we check it to say that it's fully what we believe it should be, because otherwise you don't know. So
and that plays really nicely into the discussion that I had with Lakshmi that we will play out around the single drive failure and latent sector faults, that you do need to do that validation regularly.
Right. So then the next thing is, okay, why do people do backups? It's for a recovery, ultimately. They want to
I don't want to do backups, but I desperately need to do recoveries.
That's right. So then when you do recovery, then the things you care about are the big disaster like recovery. Like the whole box has gone down.
Smoking a hole.
Smoking hole. That's an easy one. The whole thing has to come up. We already have that feature in our product. But then next question is, okay, it's not that. Somebody deleted a file.
Foolish user.
Yeah, or somebody deleted a VM by mistake, or they did something wrong, and then they just go back. They just need to go back in time a little bit. So for that, they need VM level granular recovery. They also need object level recovery, because I deleted my email. I mean, one email box, one email has disappeared because I deleted it. I got to get that object level recovery. And that was
the purchase order for a $500,000 order, so I really need that email back.
Yeah, exactly, right? So then you need to make that convenient for the end user to like be able to recover these smaller objects. So we have done multiple things for that. So this is, again, if you want to do backup, you must do these things so that you are fully like making the life easy for the end user. Not just snapshots. You got to think of the other things they do.
Full cycle, yes.
Full cycle, yeah. The full cycle data management, like, So, so we do VM level recovery, which is sometimes just need useful, and we do VMDK. The next level is VMDK level recovery, because sometimes your VMDK is messed up. And we also have partnered with Kroll. We'll do more with them in the future. But right now we have partnered with Kroll to do exchange level recovery, single email exchanges, and they also provide support for SharePoint
and SQL.
Nice.
So that's hitting the big three Microsoft apps. And,
right.
Active Directory as well, or not yet?
Active Directory, I think, I'm not sure about that one yet. So the other one is single file recovery, which gets asked quite often. Yes. But and I think we have all the tools to build it. We'll soon expose it. It's coming. I'm disclosing something which is coming in the future, near future.
All statements about future are subject to change.
That's right. That's true. But we're working on it actively. So that's the. So ultimately, what this helps you is that if you have a unified architecture, you can have many systems in across the data centers that replicate to each other or replicate to the cloud. It looks like one pane of glass to manage all your VMs and the entire life cycle of that VM. So it makes it convenient. Makes the life easier to manage. It makes your life easier on a day-to-day basis. You can just go home, not worry about all these pieces working together, and one phone call to call, there's a problem. It just makes it all convenient for everybody.
One of the other really nice things about the Datrium architecture is it's API first. So although I can do all of these things through the GUI, if I'm a service provider that needs to integrate with a self-provisioning portal, it can all be done through APIs.
That's right. So all our system management functions, like all the functions we provide in the UI, they're all done through APIs. Like, the APIs are all uniformly well done, so that we thought about future-proofing them. Some of our engineers have come from like established places, so they kind of have been through the cycle before. So we kind of all know.
Yes.
We're not discovering from first principles again all these issues. So that's the kind of where we are. We want to make life easy, unified, simple, and it's just makes everything just convenient.
Excellent. Right.
So that's all. That's the story of Datrium data protection.
Well, thank you very much, Sazzala, for spending some time to dig pretty deeply into what's going on and how and why. I'm trying to think that we have another resource about data protection. We're going to look at the results of the protection we set up on some virtual machines. And so, yeah, thank you very much for joining us. Thank you very much,
Alistair.
We're going to switch you out and switch back in the blue shirted Devon.
Okay, awesome.
Thanks very much.
Thanks very much.